Chapter 1, Section B, we're going to look at doing conversions. So what a conversion is, it's the change in the form of a measurement without changing the actual amount. So if you were going to run a 5K, so 5 kilometers, and you wanted to know how many miles that was, you would end up doing a conversion to go from kilometers to miles. Now once you figure out how many miles are in that 5 kilometers, they're still equal to each other. You're not actually changing the amount, you're just changing the units themselves. The numbers may be different, but the distance is still going to be the same. So let's look at how you would complete this conversion. So with conversions, you are going to need a conversion factor. And what a conversion factor is, it's the number used to change from one set of units to another, and it usually involves multiplying or dividing. So in order to go between kilometers and miles, since kilometers is a metric unit and miles is an English unit, we would have to look up a conversion factor. And the factor that I'm going to use is here in yellow. So I have 1 mile is equal to 1.6 kilometers. And how I'm going to use that is I am going to place it next to my original amount. So I'm starting with my 5 kilometers. I'm going to then use my conversion factors, putting the kilometers on the bottom so that they cancel, and leaving my miles on top. And what I'm actually doing here is I'm dividing. I'm taking 5 and dividing it by 1.6 to get a total of 3.1 miles. So 5 kilometers is equal to 3.1 miles. The numbers are different, the units are different, but the actual distance is the same. Let's talk a minute about exact numbers. So that conversion factor that I showed you a moment ago, going from kilometers to miles, that's an exact number. It's a number that contains no uncertainty. It is found by definition. So I found that conversion factor going from kilometers to miles in a table of conversion factors. It was defined that way, so that's how I know it's an exact number. So the takeaway from this is when you're using conversion factors, when you're using exact numbers, they will never determine the number of sig figs. So you're not going to include them when you're trying to figure out how many sig figs should be in your answer. We'll go through some examples applying this so make it a little bit more clear. So here is a conversion factor, an example of one. Now conversion factors are usually written as an equation. So for instance, 1 yard is equal to 3 feet. Now this would be a conversion factor that I would find on a table, so it would be an exact number. So if I were to use this conversion factor to convert from yards to feet, I would not use these numbers in the conversion factor towards my sig figs. Now, since conversion factors are set equal to each other, we can write them in 2 different ways. We can write them as a fraction with the yards on top in this first example here and the feet on bottom. Or we can write them with the feet in the numerator and the yard portion on the bottom. Now this is going to be helpful when we're doing conversions because sometimes we're going to need the feet on the bottom to get units to cancel. Sometimes we might need the yards on the bottom to get units to cancel. There are also multiple conversions for the same relationship. So what I mean by that is sometimes you might find more than one conversion factor that works. For instance, if you needed to convert from millimeters to meters, you could use this direct conversion up here. I'm going from millimeters to meters, or this memorized conversion, also going from millimeters to meters. Now notice the numbers in front are different. So I have 1 millimeter in the top is equal to 10 to the negative 3 meters. The bottom conversion factor has 1,000 millimeters equaling 1 meter. It doesn't matter which conversion factor you choose, as long as we are canceling out the units we don't want and keeping the units we do, it will still work out. They are actually the same conversion factor, and that's what this is showing here, that when you put them in fraction form, they are still both going to be equal to 1. Now let's look at a unit conversion example. So I'm just going to show you what it looks like when we're trying to cancel out units and keep other units. So this is just going to be with the units. We're not going to involve any numbers quite yet. So this example here is going to go from milligrams to cc's. And a lot of you going into health-related fields have heard of cc's before. That is just centimeters cubed. So starting with the number of milligrams. So whenever you're starting a conversion, you always start with what's given. What you're starting with in this case is going to be milligrams. And your goal is going to be to get to cc's. Now you probably won't find a direct conversion, so it's going to take several steps. So in this example, we are going from starting with milligrams, then using the next conversion factor, we're going to go to grams. The next conversion factor will get us into liters. Then we will go into milliliters, and last but not least will be in cc's. I wanted to show this example how I would write it on the board, because this is a method that I call railroad tracks, where you're drawing a horizontal line, which is the division line. All the vertical lines are multiplication lines. And the nice thing about setting up conversions this way is that units that are on opposite sides of the horizontal line cancel each other out. So this is where it's useful to be able to represent conversion factors in two different ways, with the milligrams on bottom or the milligrams on top. That way you can pick and choose which way is useful to you in that specific conversion. So you'll notice here, when we're just looking at the units, that the milligrams are on opposite sides of the horizontal line. What that means is we're taking milligram divided by milligram. So those units are going to cancel. So after this first step, I'm going to be left with grams. So then I want to find a conversion factor to get rid of the grams. So that's where this next conversion factor comes into play. And when I put it in my railroad tracks, I'm going to put the grams on bottom so that the grams and grams are now on opposite side of the horizontal line, causing them to cancel as well. Moving on, I am now in liters. I want to get rid of the liters because remember, I'm trying to get all the way to cc's, cubic centimeters. So to get rid of liters, I'm going to find a conversion factor and put the liter portion of that conversion factor on the bottom in the denominator so that they're on opposite sides of the horizontal line, thus canceling each other out. Last but not least, milliliters. To get rid of that milliliters, I will find a conversion factor and place it so that the milliliter portion is in the denominator, canceling that out. So normally there would be numbers in front of all of these units, and you would then multiply and divide accordingly. And once you're done, since all of the units canceled except for the cc's, your answer is going to be in cc's. Now this is an extreme example. We're going to start with just 1 or 2 steps. This particular one had 4 steps, I believe, so we'll work our way up. So let's start by looking at this conversion. We have 0.75 quarts and we want it in liters. So in order to do that, this is English to English conversion factor. We're going to have to look up in our table some conversion factors. Now, there can be more than one conversion factor to get you to the right answer. And it doesn't matter which conversion factors you choose, as long as you are canceling out the units you don't want and keeping the units you do. So I've written two different ways, and it depends upon the person which conversion factors they happen to find first. So the first way is going to be 2 steps. So using this way, we're going to go from quarts to gallons first, using this conversion factor here. Once we're in gallons, we'll then get to liters by using this conversion factor. 1 gallon is equal to 3.78 liters. So it's a 2-step conversion. Now, if you were lucky enough to find this conversion factor here, 1 quart is equal to 0.946 liters, you could have changed that to just a 1-step conversion, because this conversion factor will go directly from quarts to liters, and you won't need a second conversion factor to continue. So what I'm going to show is the 2-step method, just so you can see how things are canceling in a multi-step conversion problem. So you always start with what's given in the problem. So since the problem is starting with 0.75 quarts, that's how you're going to start your railroad tracks, is with that 0.75 quarts in the numerator. You're then going to figure out which of the 2 conversion factors you need to use first. Now, you're trying to get rid of the quarts, so you're going to want to pick the conversion factor that has quarts in it. So that's why I chose to use the 1 gallon is equal to 4 quarts conversion factor. Now, since it's set equal to each other, remember, we can write that conversion factor in 2 ways. We can write it with the gallons in the numerator or with the quarts in the numerator. We chose to put gallons in the numerator because that's the unit we want to keep, and we put quarts in the denominator so that quarts and quarts cancel, because they're on opposite sides of that horizontal line. So by putting the 4 quarts in the denominator, we have canceled out the quarts units, and if we were to stop there, our answer would be in gallons. We don't want our answer in gallons though, so we're going to continue on using the second conversion factor, where 1 gallon is equal to 3.78 liters. When we're using that conversion factor, we're going to put gallons on the bottom in the denominator so that the gallons now cancel. So now I've canceled all the units. My answer, once I do my multiplication and division, will now be in liters. Now remember, these vertical lines are multiplication signs, so I'm multiplying across. So I'm going to take 0.75 times 1 times 3.78. I am then going to divide it by whatever's in the denominator. So in this case, 4 times 1. The answer that comes out on my calculator is 0.70867 liters. But remember, we still need to check significant figures. We didn't learn those for no reason. We learned them for problems such as this. So, how do you determine significant figures? Remember, we do not use the conversion factors in our determination of sig figs. So we're just going to use the original number in the question, the 0.75. There are 2 sig figs in 0.75, so that means I should have 2 sig figs in my answer. Since I'm multiplying and dividing, remember we're using significant figures as a whole, so that's why I'm counting total sig figs and not just after the decimal, which I would do that if it was addition or subtraction. So 2 sig figs, that means the 7 and the 0 are the 2 I want. I look to the number next to it. That 0 is going to become a 1 for my final answer of 0.71 liters. Let's look at some conversions that we might see in everyday life. So how much would the gas cost for a round trip to Dallas, Texas? So in order to figure that out, you need to know how far your destination is, 318 miles, how many miles per gallon your vehicle gets, and then of course the cost of gas. So these are all going to help us figure out the total cost. So it says round trip, so that's why in this first step we're taking the 3.18 318 miles, and we're multiplying it by 2 because this 318, that's one way. So we're multiplying it by 2 for the round trip. So that is going to give us the total miles of the trip. So notice I'm keeping my units next to my number so that once I get my conversion factors ready, I know what's going to go on top and what's going to go on bottom. So the car in this case gets 33 miles per gallon. So miles per gallon, that's a conversion factor in itself. It's saying that I have 33 miles per 1 gallon. So I'm going to put the 33 portion on the bottom because that 33 is representing the miles. And I want the miles on opposite sides of this horizontal line. So by putting my 33 on the bottom, I'm canceling out my miles. Now my per gallon, my per 1 gallon, that's going to go on the top. So if I just do this conversion and stop there, what I'm figuring out is how many gallons of gas it's going to take to go round trip to Dallas. But I don't want to know how many gallons, I want to know the money. How much is it going to cost? So that's where this next piece of information is helpful. And this is how much 1 gallon of gas costs. So it's $2.349 per gallon. So I'm going to put the gallon portion on the bottom so that they cancel opposite sides of the horizontal line, leaving the money portion on top because that's what I want my units in. I want to know the money, the cash. So to solve for how much money, you're going to multiply across. So 318 times 2 times the amount of the gas and divide by everything in the denominator, which is just the 33 times 1. Make sure you're rounding to 4 significant figures because all of our numbers have 4 significant figures. And it will cost $52.39. So here's just a list of steps for dimensional analysis. All dimensional analysis is a big word for conversions. So the first thing you want to do when approaching a conversion problem is figure out what are the given units, what are the desired units. What type of units am I looking for? Am I doing English to English? Am I doing a metric to metric? And we'll talk about that when we do problems on the board. Or am I doing English to metric? This is just going to help you figure out where on your conversion factor sheet to go, where to look. It's going to narrow down the area of that sheet to look in for the correct conversion factors. We're still going to approach all these problems in a similar fashion. Next, write down the relationships needed. So what conversion factors are going to help you get from one to another? Okay, so write those down off to the side so that you have them ready and can put them into your railroad tracks as you go. Make sure that you are setting it up so that units will cancel out that you don't want and units you want to keep will stay. Last but not least, multiply the numbers and divide to get the correct answer. So here are some conversion examples that we're going to go through during class period. Try these on your own with what you've seen so far. Some of them get a little more difficult when we talk about meters squared and centimeters squared, and then also when we're looking at multiple units, converting between multiple units at the same time. So some additional experimental quantities that we're going to see are temperature, density, and specific gravity. So all we're going to cover in this PowerPoint is just the temperature part. We'll look at density and specific gravity in the next one for Chapter 1C. So with temperature, it's a measure of the heat content of a substance. When you take the temperature of something, you're seeing how much heat is contained in that substance. So it's basically what we measure with a thermometer. So we're going to look at Fahrenheit, degrees Celsius, and Kelvin. Now I want you to note that Kelvin does not have an a degrees sign because Kelvin is an absolute scale. So 0 Kelvin is the lowest you can go. You cannot go into the negatives with Kelvin. That's why there's no degrees. With Celsius and Fahrenheit, you can go into negatives, right? We can have -8 degree Fahrenheit weather. You can have negative Celsius as well. So all I have here is a comparison using water as a baseline, where you can see the temperatures that water will freeze or melt in Fahrenheit, Celsius, and Kelvin, and you can also see the temperature at which water will boil in all 3 units, Fahrenheit, Celsius, and Kelvin, just so you can compare. We're going to be looking at, in the next section of the chapter, we'll talk about physical and chemical properties. We'll also talk about intensive and extensive properties. So we'll discuss whether temperature is a physical or chemical or an intensive or extensive properties. So just be prepared for that. So here are the equations that we will be using to do these temperature conversions. So it's not our typical conversions where we do railroad tracks and we have a conversion factor. Instead, we're going to be using these equations and just plugging in for the unknowns. So this first one, going from Fahrenheit to Kelvin, or sorry, Fahrenheit to Celsius, excuse me. To do that, you're going to use the equation where Celsius is equal to. So where this F is, that's where you're going to put the Fahrenheit amount. So you're going to take whatever degrees Fahrenheit the problem gave you, subtract 32 from it, and then divide by 1.8. Now the trick with this equation is make sure you're doing that subtraction portion first, so the Fahrenheit minus the 32. Do that first or put it in parentheses in your calculator before dividing it by 1.8. Otherwise, by orders of operation, your calculator will do 32 divided by 1.8 first and then do the subtraction and you'll get an incorrect answer. To go from Celsius to Fahrenheit, we're going to use the following equation. It's really the same as the previous, it's just rearranged to solve for F instead, for Fahrenheit instead. So to solve for Fahrenheit, you're going to take 1.8 times Celsius, whatever degrees Celsius was given in the problem, and add 32 to that. So it's really just plug and chug type problems. Now to get to Kelvin, we only have one equation. And that is taking whatever degrees Celsius you have and adding 273 to it. Now some books say 273.15, others just round it to 273, a whole number. Either one you use is going to be fine. Just pick the closest answer in multiple choice. So notice to get to Kelvin, you have to have it in degrees Celsius. So the most difficult type of problem you'll encounter is where I give you the Fahrenheit temperature and ask you for the Kelvin, because that's going to require you to do 2 steps. You're going to have to convert from Fahrenheit to Celsius first, and then once you're in Celsius, you can then use the above equation to get to Kelvin. I realized I almost spelled a bad word. All right, so here are some temperature calculations that we're going to be doing in class, working between Fahrenheit, Celsius, and Kelvin. You can go ahead and try them on your own. That is all for Chapter 1B. Stay tuned for Chapter 1C.